Alright, so on number 46, we have the given triangle on the image. Now, first thing that we could do, there's more than one way that you can do this problem. It asks you to reflect it over the y-axis. So, first thing you could do is identify the points. So, this point is at -1, -2. This point up here is at +1, +2. And this point is at 1, 2, 3, 4, 0. Now, you could use the property of, if we're reflecting over the y-axis, we're going to change the x value. We change the opposite value's sign. So, L, all we're doing is changing the x on this, so it would become 1, -2. For M, we change the x value so this would become -1, +2. For N, we change the x value here, which is 4, to -4, still 0. Again, nothing else changes if you're flipping it over the x. The other way you could look at this is actually look at distance from the y-axis and draw it as a picture. So M, it's 1 unit away, so I go 1 unit away on the other side. This would be M prime. Notice, same coordinate. For N, 4 units this way, so go 4 units the other way. That'd be N prime. This is L, 1 unit this way, so go 1 unit the opposite way. This would be L prime. And then you have your image like that. Oh, man, I was off there just now, wasn't I? Alright, not the best example, because I screwed up. I wasn't 4 away on the one. There it is. Ignore these 2 little lines here. I said -4, 0, and I only counted 3. Looks good. Alright, moving on to the next question. 47. Now, this page was lots of similarity, and I actually did most of these problems already on the video from tutoring. I'm just going to go in order real fast. So, on here, 47, we had GA is 16, this piece here. AP is 20, that's this piece here. NP is 25. We want GN. So, essentially, anytime we're doing this problem, let me just go ahead and set up my proportion here. If I did NP over NG, it should be equal to AP over GA. Alright? And that's the same proportion that I'd have to use for both 47 and 48. So, if I just plug these in, I should have the right setup. So, GA is going to go down here. AP on the top. NP on the top over here. And we're looking for GN or NG, so this one down here. Cross multiply and solve. Again, if we can simplify, simplify. So, divide both of those by 4. You get 5 over 4. 5 times 25 is 100. 5 times x is 5x. Divide by 5, and you get 20 equals x. And that's what we're looking for. So this one's 20. For 48, again, same setup. So since I already set it up in terms of the values I needed, just going to plug into that again. NG, again, that was on the bottom. So 15. NP, that went on top of that, so 18. Now, this one, this isn't one of the values in here. This is this entire side. So that one's a little tricky, because in terms of 25, we're trying to find GA, so I'm going to go ahead and write X there for GA. But then for the other part, AP, I have to do it in terms of X and the 25, the whole. So I have to do the whole thing, 25, minus the X, which we're using for the other piece. So 25 minus X will be the top. Cross multiply and solve. Again, if you can simplify, simplify. These both can be divided by 3, so that'd be 6 and 5. So now, cross multiply, 6 times x, 6x. 5 times this, you got to distribute the 5, so that's 125 and 5x. Bring this 5 over this way, and we're going to add it, so that's going to be 11x equals 125. Divide by 11, 125 divided by 11 is 11.36. We'll round it there. So for 49, again, same image. They gave us different numbers again. GA. I'm going to do my work over here this time. GA is 12. AP is 2x plus 3. NP is 5 plus x. GN or NG is 15. So again, I use that same outline that I had up here, put them in the same order every time. Cross multiply and solve. I can't reduce on this one, but I'm going to have to distribute. So 12 times 5 is 60 plus 12x. 15 times 2x is 30x. 15 times 3 is 45. Combine like terms. Bring the 12x this way, so we're going to subtract the 12x. We're left with 18x. Subtract the 45. That leaves us with 15. Divide this all by 18, so 15 over 18 equals x. Now, that's not one of our answer choices, but we can reduce that. Both of those are divisible by 3. So, divide by 3, this would be 5, this would be 6. A is our answer. Alright, on 50. A triangle has sides 12, 14, and 20. The smallest side of another similar triangle measures 8 feet. So 8 has to go with the smallest one up here, 8 and 12. So 8 goes with 12. We want the perimeter. Well, for the big triangle, we can figure out the perimeter. Again, we're looking for the perimeter of the small one, so x will go on top. Perimeter of the big one, add all those up. 12 plus 14 plus 20. 12 plus 14 is 26. 26 plus 20 is 46. So again, those three added together is 46. That's the perimeter of the small one. Cross multiply and solve. We don't have to solve for each individual piece because the perimeter is still considered distance, which is a single dimensional measurement. So you can still use that same scale factor, same ratio to find your perimeter as well. Again, if you can simplify, simplify. 8 and 12, both divisible by 4, so that's 2 and 3. So cross multiply, 3 times x, 3x. 2 times 46, that'd be 92. Divide by 3, it doesn't come out to a whole number, so that's 92 over 3, which 92 divided by 3, 30.6 continuous. On 51, the diagram may not be drawn to scale. Well, instead of above, that should have said below. Alright, but yeah, our diagram, it says triangle RST is similar to triangle UPQ. Find the value of x, round to the nearest tenth. So they told us what order everything went in. X is on side UP. UP goes with RS. So x goes over 20. So x over 20. Then the only other piece we have here is QU. So we're going to do that one on top. QU is in the same places as T and R. So TR is 29. Cross multiply and solve. 50 times 20. That's 1,000. Equals 29x. Divide by 29. 1,000 divided by 29. 34.5. Which is A. 52. Find the value of x, round to the nearest 10th place if needed. Again, this is one of those things that was on our last test. So we have x over 8 equals, now, in order to find this one, I'm using the actual triangles. I'm not using the proportional theorems, proportionality theorems. I gotta use the actual triangles because these are on the parallel lines. So when I do the other sides, 10, not over 14, over this entire side is going to be for the big triangle. So over 24. So we can reduce that. That'd be 5 and 12. Cross multiply. 5 times 8 is 40. Equals 12x. Divide by 12. 40 and 12. Again, depends what your answer choices look like. If it's a decimal, you want to change this to decimal. If they're fraction options, you want to reduce this fraction. So let me reduce this first. They both reduce by 4. So we could say 10 over 3 as an answer. Or if we change it to a decimal, it'd be 3.3 continuous. Again, either one of those is an acceptable answer. Just depends on what your multiple choice answers are, whether they're fractions or decimals. Again, it said round to the nearest 10th on that one, so the way it asked the question, it'd be that. But again, on the test, it might be a decimal, they might be fractions, whatever. On 53. In the figure below, we have these two triangles are similar. Again, they give us a similarity statement so we know which ones match up. And they have these labeled, that is 75, that one's 50. What is the measured angle B? So this is the one we're trying to find. So we need to know what O was as well. Well, O, if we look at this, matches up with A. So this one is 75. We need to now find B by subtracting off the other two. So minus 50, minus 75. So if we have 180 minus 50, that would be 130. Then subtract off 75 from that, and you're at 55. So that would be this angle, 55. On 54. Again, this is very similar to the other one we just did with perimeter a few moments ago. If we find the perimeter of this one first, that's going to help us out. So 6 plus 4 plus 5 plus 6.5 plus 7 gives us 28.5. That's the perimeter of the small one. These two are corresponding, so we have 10 and 6 will be equal to x, the perimeter we're trying to find, over 28.5. Again, we could reduce this by 2 and get 5 over 3. Cross multiply. 3x equals, let's see, 28.5 times 5 is 142.5. Divide that by 3, and we get 47.5. And that would be our answer. Right. On to the next one. 55. Flagpole. We have flagpole and guy. It's at the same time of day, they would cast the same type of shadow because the sun would be in the same location. We know that these two have to be similar figures because those are both right angles, and then the angle up to the sun would be exactly the same. So, they gave us the measurements. He's 6 feet tall. He casts a 5-foot shadow. At the same time of day, the flagpole casts a 9-foot shadow. So we have similar figures here. Set a proportion, cross multiply, and solve. X would match up with the 6. 9 would match up with the 5. Cross multiply. 5 times x equals 54. Divide 54 by 5, and you get 10.8. So that's A. On 56. on 56, we have both these lines are parallel, both these lines are parallel. So we actually have 3 similar figures here. There's more than one correct way to solve for most of these. First thing they ask, though, is how do we know that these are similar? Well, we know that they're similar because we have parallel lines, and when we have parallel lines, we're going to have angles that are corresponding, and they'll be congruent. So those are all congruent angles. So this is AA. All right, shh, guys. Now, BC is the first one we're trying to find. So let's put some of these numbers on this figure. AE is 10. EC, that's this entire length, is 8. AC, which is this length from here to here, is 9. FD is 12. HC is 6. Now, I may or may not solve these the same way that I did on the tutoring video, because there's a lot of different options here. But for BC, all right, so I'm going to call this one X for purposes of finding it. So to find that side, X equals, X over, I need another value there. X over, I'm going to do the 9. It's in the same position. Is equal to 6 is the only other part of the small triangle I have, and it's in the same position as 8. Again, I did small triangle over medium-sized triangle, so I did small over medium-sized again. We could reduce. That'd be 3 over 4. Cross multiply. 4x equals 27. Divide by 4. 7 divided by 4 is 6.75. Then for BH, I'm going to call that Y. Again, we can use the same 2 triangles, the small and the medium. So Y over 10 equals 6 over 8. Cross multiply and solve. 60 equals 8Y. 60 divided by 8. 7.5. Now, for HF, I'll take a question in just a second. Let me do Z. All right, for HF, if have somebody out. Wait in a minute. HF. All right. So this one, I'm going to call it Z for now. Now, one thing that you could recognize here is that this small triangle and the big triangle, so we're going to have to use the big triangle here. The big triangle compared to the small triangle, what's the scale factor there? 2, right? If we went from 6 to 12, that doubled in size. So we could just use the scale factor and actually make this problem a little bit easier, because if I know that this doubled, then this side also has to double, right? We already found what Y was. Y, we just said, was 7.5. So if that piece is 7.5, this whole thing is 15. So this other half is also 7.5. So we don't even have to really do a whole lot of math to get the last one. If you wanted to, you could set up a proportion like we did on the other 2. But again, you don't have to. All right. On 57, if angle R is congruent to angle N, then find these pieces. Well, again, those 2 are congruent, and we know vertical angles are congruent. Kenny, just put the sand away.
He's like, are you having a good day? You seem a little triggered.
All right. So again, we have RO and this one, AN, are in the same position. So in order to solve for RO, I'm just going to use RO in my proportion this time, and put it over the 15 in the same position. And then 8 and the 10 would be in the same position. So 8 and 10. Again, we can reduce, be 4 and 5, cross multiply. That'd be 60 divided by divide by 5, and you get 12. Then for OF. OF is in the same position as the 12. We can use the same the same ratio over on the other half of the proportion, which it reduced to 4 and 5. Cross multiply and solve. 4 times 12, 48. Divide by 5, 48 divided by 5 is 9.6. And that's it. On 58. Faith, who will play ball on a new type of field shown below, will be the pitcher. They will stand equal distant from Maria and Linda and Brenda. So we need a point that's equal distant to those three people. What point is equal distant in a triangle to three of the vertices? It is the circumcenter. Again, the circumcenter is the center of a circumscribed circle that would go around the triangle, which goes through all the vertices. Therefore, it's equal distance to all those vertices. All right, on the next one. 59. 59, which cannot be a triangle. Now, triangles can usually have two ways of defining them, both as based on the number of the length of the sides and the measures of the angles. So, having a right isosceles triangle, that's possible. That works. You can do that. Having an obtuse isosceles, that also works. We could draw that if we wanted to. Equilateral and acute. Well, equilateral triangles are also equal angular. And equal angular triangles all have measures of 60 degrees. Is 60 degree acute? Yes. So all of them are acute, so it can also be called an acute triangle. So that works. Obtuse and scalene. Yeah, we've had plenty of examples of obtuse and scalene triangles. So far, all of these have worked. Right and equilateral. We just said a second ago, if it's equilateral, it also has to be equal angular, which means all the angles have to be 60 degrees. So can it be a right triangle? No. So E is the one that doesn't work, because you can't have all the angles be 60 and have one right angle. Doesn't make sense. On 60, complete each statement. Every point in a plane which is on the blank is equal distance from the sides of the angle. So that is the angle bisector. So these are straight definitions. Again, you need to know these terms. Every point in a plane which is on the blank is equal distance from the endpoints of a segment. This would be the perpendicular bisector. C. The point called the blank is equal distance to the sides of the triangles. So, equal distance to all the sides is the incenter. Equal distance to all the vertices is the circumcenter. Alright, on 61. These are all what we would call either a mid-segment or median of a trapezoid. So, they give us 32. They give us 20. They want us to find the other piece. The mid-segment, sorry. The mid-segment is the average of the two bases. So, if we're finding the mid-segment, we do the average of these. If we're given the mid-segment, you can do kind of like the snowman method, like we did with our midpoint. We know the difference between these two is 12, right? You subtract the 12. So if you subtract 12 more, we should be at the other base, which would be 8. That's our answer. On this one, they give us the two bases. They give you the two bases and they're looking for the mid-segment. That's where you want to do an average. So 20 plus 42 divided by 2. 20 plus 42 is 62. 62 divided by 2 is 31. That's the middle. On this one, they give you 22. They give you 42. Same idea. We want the middle. What is it? Do the average. Average of the two bases. So that's 64. 64 divided by 2 is 32. That's it. On 62, it tells us that we have a trapezoid with these bases. So these are the two bases. I'm going to mark them as parallel so that we know that those are the two bases. This angle is 132. They want to know angle A. Well, to get this angle, these two angles have to be what? Supplementary. So 180 minus 132 leaves us with 48. That's that angle. All right, next page. Given the following statements, name the quadrilateral that must be. Parallelogram with equal sides. That's a rhombus. Parallelogram with perpendicular diagonals.
It's more than one shape.
But which one does it have to be?
A rhombus.
It has to be a rhombus. By definition, that would be a rhombus. Parallelogram with four right angles. That is a rectangle. Quadrilateral with only two pair of parallel sides. Parallelogram. I don't know why they put only. That throws you off a little bit. So this is a parallelogram.
Can there be more than two?
No, you can't have more than two, but it's funny that they phrase it that way. Usually for a trapezoid, you phrase it as a quadrilateral with only one pair of parallel sides. But you're using all the sides if you say two pairs of parallel sides. So there's no reason to use the word only there.
Can something have three?
Now if it's a quadrilateral. But if you had a regular hexagon, you'd have three pairs of parallel sides. But again, we're not to those shapes yet. All right. Guys. 64. Given that the diagram below is a parallelogram, find the value of x. So, opposite sides have to be congruent. So we can set these equal. Now, that's not the only way to solve this problem. So we can set them equal and solve. Bring the 4x this way. Bring this that way. It's 25. Wait.
What was that? You can see that. You singing the song? 25.
That's what it is. It works when you plug it in.
See, I think they made a typo on this question because there's more than one way to solve it. Let's check to see what you get if you do this a different way. Because these two should add up to 180.
Subtract 70.
It should work.
70.
25. It's
It's still
still 25.
25. It's still 25. Well, that's a horrible question. The answer is 25. It's not there. None of the above. All right. Didn't mean to. All right. 65. Rectangle RSTU has diagonals that meet at point X. What do we know about all these pieces? They're all congruent. So if RX is 4X and ST, this entire thing is 100, so that means each half of this is 50, and XU is 5Y, what's X and U? Well, both of these would have to also be equal to 50. So for Y, just divide by 5 and you get 10. For this side, divide by 4, and you get 12.5. And that's it. All right. 66. The quadrilateral has all sides equal, which cannot describe that quadrilateral. A rhombus has all sides equal. Regular has all sides equal. Equilateral has all sides equal. A square has all sides equal. A trapezoid can never have all sides equal, so that's the one that doesn't work. On 67, this is a parallelogram. These two have to add up to 180. So 180 equals 120 plus 4x plus 12. I bring the 120 over first, get down to 60. Bring the 12 over, that brings it down to 48. 48 divided by 4 is 12, and that's x. On 68, this is again parallelogram. These sides, or these angles, opposite angles are congruent, so set them equal. Subtract 12, you're at 68. Divide by 4, and that's 17. All right, on the next page. Part 1 of this diagram. They want to know what are the coordinates of the midpoint of AC. So, midpoint formula. That's x1 plus x2 divided by 2. y1 plus y2 divided by 2. It looks like they listed D first in all the ones that have D in it, so we're going to use D first. So D plus negative 2 over 2 and 3 plus 0 over 2. Reduce it. This would be D minus 2 over 2. This would be 3 over 2, which is, oh, nope, not that one, I lied. That's a little too fast for circling. S. That one looks almost exactly the same, but there's a plus sign. We need a minus sign. What is the length of the shorter diagonal? So this would be the shorter diagonal in terms of W. Distance formula. I'm going to write distance formula up here for just a second. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So, square root of 2 minus negative w squared plus 0 minus 3 squared. Now, it doesn't say how far to simplify this, so there's lots of places you probably could have stopped with this. I could have said 2 plus w squared plus 3, no, sorry, not 3, plus 9. If you wanted to square this, then that becomes a little bit longer of a problem. You'd have 4 plus 4w plus w squared plus 9.
I ended with square root of 4w plus 4.
And you could combine that. So w squared plus 4w plus 13. I think that's the simplest form, that one. But again, I really don't think they're going to have anything that hard on the test. If they do, it's multiple choice, so you'll be able to see how far they want you to take it.
God bless you. I meant. You know what I meant? God,
Yeah.
God calls you.
All right, on 70. In the parallelogram, BRAT, S is the intersection of the diagonals. If SB is 4x minus 12, and RS is 6x plus 8, and SA is 3x plus 10, find the value of x. Well, what we know is the opposite parts here are being bisected. So these two have to be equal. So set those two equal.
We're not doing anything, don't worry. No, we're not doing anything bad.
Find the lengths of each diagonal. So plug in the 22. If I plug in 22, 4 times 22 is 88. 88 minus 12, that'd be 76. Right? So, on this one, plug the 22 in. 6 times 22 is a lot. 6 times 22 is 132, plus 8 is 140. Now, they want the length of each diagonal. So, BA, that entire length, you got to double that. That's 152. RT, you have to double what we just found for this one. So that'd be 280. And those were the lengths of the diagonals. All right, for the proof. All right, this sounds like it might be the last problem with that Bella over there at lunch. So, given, again, you can put the given in.
The funniest one we were doing it.
And because of that given, we know that these two are congruent. So ADB is congruent to CBD because of alternate interior angle theorem. We also have AD is congruent to BC. That was given. We have BD is congruent to itself. Reflexive. See you tomorrow. I'm going to finish this problem on the video and then have a good weekend. Huh?
Not mad at us, right?
No.
Oh, I've never been over there.
All right, so we have reflexive. You now have 3 parts. These 3 parts are congruent. So we have 2 sides and an included angle. So by SAS, you can say the triangles are congruent. Triangle ADB is congruent to triangle CBD. Once you know the triangles are congruent, all the corresponding parts are congruent. We're trying to prove that we have lines parallel, so we need to know that the alternate interior angles are congruent. So ABD is congruent to CDB because of CPCTC. And once you know that those angles are congruent, you can then say these sides are parallel. So AB is parallel with CD because of converse of alternate interior angle theorem. And that's it for that.